Welcome to the Hudson Institute. I'm Bryan Clark, a senior fellow at the Institute and the director of the Hudson Center for Defense Concepts and Technology. Today, we're here to talk about next generation air dominance, which is the DoD's program to replace some of its frontline military jets with a new combination of manned and unmanned systems. Both the Navy and Air Force are pursuing versions of what we call NGAD. We're going to talk mostly today about the Air Force's version of NGAD. Now, most of the capabilities associated with NGAD are going to be highly classified. And so we won't get into details about specific capabilities of systems that are going to be included in NGAD and some of the aircraft that might be included. But overall, we're going to be talking about mostly NGAD as a case study and a new approach to acquisition and research and development that's focused around what we're calling mission-focused teaming. So this idea is we should be building force packages in NGAD around a particular mission, composing them to conduct a specific set of tasks in the situation that they're living in at that time. So not well in advance before they deploy, but actually once they're deployed in the environment where they're going to be fighting. By doing this mission-focused teaming, it connotes two different things. So one is this idea focused on mission. The other thing is this idea of teaming. And I think that word gets thrown around a lot. But one thing that comes out in it is the idea like a sports team, where each individual member of the team is born and grows up and is developed independently of other members of the team. They come together in a particular formation to conduct a set of plays. They may then come apart and either form different formations down the road or even join different teams. So this idea of teaming is really important from both the standpoint of how you develop systems to be able to work together, but also the fact that they're not necessarily joined at the hip throughout their entire lives, like you might expect with systems that DoD pursued in the past. So at the heart of this idea of mission-focused teaming really is software. And so it also means that to a greater degree than it has been in the past, software is really central to developing these future combinations of systems like NGAD. They're going to be delivering capability out into the 2030s and beyond. And so to have this discussion today, we have a great panel, and I'm joined by my colleague, Dan Patt, who is a senior fellow here at Hudson as well. Dan and I co-authored a paper on new acquisition approaches for NGAD that's going to be coming out shortly and will be available on the Hudson website, as well as the page where this video is. We're also joined, though, by two esteemed Air Force officials and former officials. Dr. Timothy Grayson is a special assistant to the Secretary of the Air Force. He previously, until just about a year ago, was the director of DARPA's Strategic Technology Office, where he oversaw development of capabilities across command and control, sensing, mission management, and most importantly, mosaic warfare, which is a project that Dan and I worked on as well. Prior to coming to DARPA, Dr. Grayson worked in a variety of fields inside defense. He founded a consulting firm, Fortitude Mission Research. He also was a senior intelligence officer at the CIA and a program manager at DARPA. And he has a doctorate in physics from the University of Rochester. Also joining us is General Mike Holmes, who is now a senior advisor at the Roosevelt Group, but previously, until 2020, was an Air Force officer. He retired as commander of Air Combat Command, which is an organization overseeing over 1,000 aircraft, 11 Air Force bases with an annual operating budget of more than $7 billion. And he had previously been Deputy Chief of Staff for plans and programs, as well as being a commander at every level inside the Air Force. We're really happy to have both General Holmes and Dr. Grayson with us today. And I'm going to turn it over to Dan Patt, who's going to start the questioning, start the discussion. Thanks a lot, Dan, for being here. And thank you both, General Holmes and to Dr. Grayson.
All right. Thanks for the lively intro, Bryan. Thanks to our audience for being here. Let's just dive right in. So Tim, thanks for being here today. You managed to always seem to find a way to be right in the center of the action. So tell us, there's been a lot of talk, a lot of discussion out even in the general press about the Air Force's operational imperatives. Can you give us a sense of, what's in the mind of the Air Force these days? What's driving those?
So, thanks, Dan. It's a pleasure to be here as part of the panel today. And I'll tell you, the OIs are pretty much my entire reason for existence right now. They're why Secretary Kendall brought me into the Department of the Air Force. And it's really two things that are mutually connected. First is a recognition that we have to be able to focus Department of the Air Force on the pacing challenges. And that means being able to win and prevail in a highly contested environment against a peer adversary. And that means China, or Russia, but most importantly, China. We are clearly don't have capabilities that in the current posture can necessarily prevail. So the other part of the operational imperatives is creating a very operationally focused approach to Air Force modernization. So we're simultaneously trying to create the strategy to be able to win against a pacing threat, while at the same time modernizing the future Department of the Air Force. And it is Department of the Air Force, so it includes Space Force as well as Air Force. One of the things that really excited me, and I know, Dan, you and I have worked a lot on this type of thing in the past, it is the operational aspect of operational imperatives. So fundamentally, it's not the classic, I'll call it requirements waterfall drill of trying to develop new capabilities. It is truly trying to develop new concepts for fighting. On each of these OI teams, there is an operational lead as well as a capabilities lead, and that's to be able to iteratively design new warfighting concepts at the same time we look at new capabilities to be able to field to support them.
Yeah, that's particularly exciting. One of the things that we've seen is public reference to a list of specific operational imperatives, and several that relate to future manned platforms and future unmanned platforms, including around future air combat operations. Can you just recap what the relevant operational imperatives there are that might be related to next generation air dominance or future air capabilities?
Yeah, certainly. So we have two of them. The numbering scheme isn't too important, but we call them OI3 and OI6, and they are respectively an NGAD family of systems and a B-21 family of systems. So what we're looking at there, and we can talk more about this, I think, during the course of our discussion today, but it is partially on things we're calling CCAs, collaborative combat aircraft. And so these are the figurative unmanned wingmen, although the concepts are going much beyond that. At the same time, even for the crewed platforms, it is the notion of treating things as a family of systems. So it is looking at how we're going to develop and field new aircraft, not as monolithic platforms, but as constantly evolving types of, call it architectures, for lack of a better term, or again, family of systems is the notion that all the different elements that make up a warfighting capability might be part of what we need, but in a loosely connected way. So it is certainly all of the comms, the mission system payloads, the autonomy itself, the battle management, command and control that's needed to have human machine teaming and have a human pilot be able to control collaborative autonomous platforms. But it's also the tools that are needed to collaborate amongst human teams as well.
Which that's a really interesting set of concepts we can dig into. So Mike, that makes me think about the groundwork that you laid when you were at Air Combat Command, which is really when a lot of this, the initial ideas around NGAD were formed, and this idea of a collaborative aircraft and families of systems being able to work together rather than thinking of the NGAD as an airplane that's just going to be a new version of the F-22, the so-called sixth generation fighter. How did you, at least when you were thinking about the challenges that the Air Force was facing, that the F-22 was going to have to be replaced with something to address? What was your approach to thinking through the effects chains that might be needed, and also the idea of systems, how they were going to work together and then be able to adapt and recompose over time?
Thanks, Brian, and thanks for allowing me to be a part of this panel. I think there were two lengthy studies that laid most of the groundwork. And the first one was started in the Air Force during the time when I was the A8, led by Alex Grinkowicz, that was a look at air superiority 2030. And the genesis of that study was that we knew that the changing threat was going to require new capabilities. We also knew there'd be resistance to kind of a traditional approach of spending 30 years building another, super advanced platform. And so Grinch led a team that took every suggestion they could find, every wild idea they could find, refined them down to about 100 that were independent ideas, refined that down into 3 or 4 main approaches, and over the course of the year, determined that it would take a family of systems to get air superiority in the future to control the air so that the joint force can exploit it, but that there was also a need for a platform primarily because of autonomy and the requirements for autonomy. So that was study one. And the study also concluded not just that a new platform and platforms were needed, but also that a new acquisition approach was going to be required, that we couldn't spend 30 years developing something. One, because we didn't have that to 2030, but two, we couldn't afford to go forward with something that was going to be 20 years late, which is what the normal process would have required. And then the second study was a analysis of alternatives, which is, a classic requirements document that ACC was tasked with called Advanced Battle Management System, which began as just a replacement for the E3 to answer the question, what are we going to replace the E3, which had provided the offboard sensing and command and control for controlling the air. And when that name was kind of usurped by a JSTARS replacement and a different project, we also modified that AOA to include not just the air-to-air kill chain and what was required to do that, but also the air-to-ground kill chain. And the main conclusion out of that document was that it would take a combination of manned and unmanned systems and onboard and offboard sensors to be able to get the information that you need, both to complete the air-to-air kill chain against the evolving threat and to complete the air-to-ground kill chain. So the combination of those two things left the Air Force and Air Combat Command with the desire to pursue a family of systems and sensors and connection that could be acquired in a new and different way in order to meet the timelines.
It's interesting that you were talking about basically a study looking at a follow-on to an aircraft hardware program, and then you were also looking at essentially a C3 program, and that essentially merging those together was what was necessary to be able to deliver on the requirements for both of them.
Yeah, I think so.
Yeah, which drives you to this idea of it needs to be a system of systems, and maybe that has relevance across multiple missions, and it's a matter of how you compose them to be able to deliver on those different missions.
Yeah, we'll get to that. It's certainly broader, I think, than NGAD or NJAD. The same techniques and some of the things that are developed for one OI may want to be composed and compiled into a mission plan for one of the other missions or one of the other OIs as we go forward.
Yeah, definitely.
And if I could just pile on that briefly, the ABMS as it exists today, or as we want it to exist going into the future, was another one of the OIs, which is looking at exactly this problem of how do we do composable, definable, distributed battle management to support these kinds of new effects chains and new mission-centered, types of mission engineering.
But Tim, let me pile on to that though. So if the thing that we need to operate, to be viable in the future, right, is bringing capability together. It's bringing capability from across domains, from across the DAF, from across platforms of data from different sources. If what we need to be successful is to bring those together, how can you turn around and turn this over to execution? Like, how do you decide who's responsible for what? How are you dealing with that? Earlier you said this is not the classic requirements waterfall, but I mean, this has to be one of the major pressure points about trying to figure out how to unbundle this and turn this into an acquisition program. How are you thinking about that?
So a couple different ways. First of all, the things that do line themselves closer to traditional types of procurements And we'll pick on something like platforms. There already is a program office established to look at the design of NGAD. There are things it can do, even within that traditional program structure, to allow it to start building out more of this family of systems kind of model. So for example, rather than the legacy approach, and I'll since everyone loves to pick on, I'll pick on F-35, which was really our last really big, fully integrated. It's got the communications data links, it's got the sensors, it's got the electronic warfare payload. All of that was vertically integrated with a platform program. Now we've got a model that says, okay, for management purposes, it still might be a program office that is anchored on a platform program, but there are two variants of that. First of all, it's not just buying platforms, it is buying the balance of those mission systems, but it starts buying them independently of the platform. So in coordination with the platform and what the platform needs, but it's not all done through one contract and one vendor as one vertically integrated thing. The other thing is, even within the platforms themselves, they're looking at notions of it isn't just one platform per program, but you may actually have an evolution of different platforms. Maybe it's evolution of one platform or even multiple different types of platform acquired under one program heading. So that's one cut at this. In parallel, we're looking at an alternative cut that builds off of the work that's already been done for ABMS. That and you and I have talked a lot about this in the past. The military in general, and perhaps the Air Force even more than some of the others, really struggles with this notion of how do we go buy what I'll call glue capabilities, for lack of a better term. And so things like comms relays. I don't want to necessarily own every single data link in a program like ABMS, but I need to be able to talk to all of them, or at least most of them. So whereas I might have a tactical data link being developed within a platform program office, I need a way to first connect and interoperate with that, as well as build possible relays and gateways that can go connect with other things. And that's how we're trying to structure ABMS. You also look at the battle management. And as I mentioned before, we're looking at battle management as effectively, call it software-defined nodes of distributed battle management. And so these are things, and General Holmes alluded to this in the original history of ABMS, where initially it was very much that air combat, AWAC-centric kind of view of the world, and then it migrated to other things. Now we're looking at it as, what are core fundamental functions of battle management? I've got to know what my tasks are. I know what assets I have. I know how to prioritize those tasks, assign them to assets, and send out commands. And that can be programmed in a lot of different ways, to include plugging into different platforms from these family of systems. So it is both trying to take multiple capabilities from within a family of systems and execute them within a program office, but not as a single rigid, monolithically integrated platform, while at the same time having different program offices building different pieces of the solution that can still be interoperable and work together, if that makes sense.
It does, and that's pretty exciting. I mean, there's a couple of themes that pop out there. One is this emphasis on modularity, or not really modularity, but pulling out the functions of capability, or the services of capability that, say, a mission system would provide or a platform would provide, pulling those out, and then creating an environment which allows you to recompose those as your needs change, right? So it's a much more dynamic environment. Let me turn a question over to Mike real quick. That kind of, dynamic environment where you see people taking capability and mixing it up in new ways, it certainly makes me think of tactical innovation. Are there places in Air Force history that you're aware of, and not necessarily in development, it might be in tactical operations, where you've seen that kind of dynamic recomposition, taking pieces and putting them together in new ways to achieve a mission need? Can you think of historic examples of where the Air Force has done that well, Mike?
Well, one that I would think about off the top of my head would be when the Air Force entered combat over North Vietnam in the 70s. They had platforms that were designed for the Cold War. They had some nascent, air command and control capabilities. But what they found out was that they were going to be unsuccessful in that threat environment unless they were able to integrate some new techniques in the electromagnetic spectrum, primarily jamming. So we started off flying, nap of the earth. In a crash effort, we produced and deployed some pods for airplanes to carry. They started with formations that they were directed to fly. Through trial and error, they worked that out. And eventually then that gave birth to the Wild Weasel capability that combined both jamming and listening in the electromagnetic spectrum with a kinetic ability to go kill things in real time. Now, those were all brought together kind of in one platform, or at least under the direction of one platform. But that's the kind of thing I think that we could fall back on in our history to think about how we might do this in a different way.
So what's interesting about that is it sort of makes me think of, like if you think about a team, like a soccer team where you've got a set of players, they're going to do offense and defense, they're going to do different plays. The coach has to get them to be able to form up and conduct those plays in the breach, as things go, like you're saying. But then we have to turn around and be able to build a team through the acquisition process that has those attributes, that the right set of attributes that allows them to be composed and recomposed to address the kinds of missions we anticipate having. So Tim, do we have to mirror essentially that operational approach? Like we have to essentially build a version of that software ecosystem that supports mission planning and recomposition and build that into our acquisition framework or in our program management to be able to figure out what are the different combinations of systems, what are the different sets of attributes we need to incorporate into NGAD. I guess that's really a question for both of you.
Yeah, so let's see, I heard a wonderful term just recently, systematic chaos. So what's interesting in the way I see this all evolving, this riffs a little bit off of Dan's question as well. At one level, I do see the need to create some degree of synchrony and harmonization. Whether or not it's a program office buying these different, say classes and models of CCAs and some of the supporting mission systems, whether it's something like an ABMS that works architecture and figures out how to create some of the compatibility. So you could think of, and to use your sports analogy, maybe the best way is saying I've got, a coordinator or even a separate school or camp that's building all of my offensive players or my defensive players or my special teams players. And I'm going to specialize them and build them up and build that toolbox. Then I'm going to break them apart. So one of the interesting things that's come out of the OI studies, and I can't in this forum go into details of the specific functions or missions, but we've seen examples of where you might take a CCA platform capability inspired by some of the NGAD work, but not deploy it with an NGAD. It might actually be launched and, at least for initial deployment, operated by some other additional entity. And then later on in the fight, reform a new formation, if you like, reform even a new team where, the command and control might fall over to a different platform. And we've even seen some of this in some of the studies that have been done between NGAD and B-21, where there could be a little bit of, call it dynamic mix and match there of who's going to form the offensive line, so to speak, and who's going to be the quarterback.
That makes a lot of sense, Tim. So Mike, it makes me think that, in terms of building NGAD, we're essentially going to have somebody playing the role in the program management, of that commander who's forming up different compositions and evaluating different compositions, force packages, ways of different tactics that could be employed, thinking ahead about that and trying to bake it into the system design as you're developing this team of systems in the acquisition process, which is very different than in the past, where we've sort of built our stuff, thrown it over to the warfighter, and as you've said, the warfighter then innovates, and then we eventually may roll that back into the acquisition process. Is it feasible for us to kind of pull back that operational innovation into the acquisition process?
Well, we used to, Bryan, our program offices, when we were a bigger Air Force, had a significant number of operators in them. And I could tell some stories if we had time of decisions that were saved on platforms during that old way, where there might have been a misunderstanding between the engineers and the people that would use it, and having them together made it work. It's basically taken the things we talk about in DevSecOps for software, which requires an operator, right? It requires a programmer and an operator. Now what we want to do is get to an ecosystem that allows continuous innovation or facilitates continuous innovation. And to do that, we'll need acquirers, engineers, and operators working together to get that done, I think.
There's another implication I'd like to explore with you. At least in my mental model of how air operations work today, there's a whole process of continual training and readiness, and after your equipment is delivered, operation of a unit, you leverage all of this training in order to be able to execute your mission successfully, even in the face of surprise. But if the kinds of things that we're talking about, where you aren't exactly sure all of the pieces which are going to be a part of your force package until sometime shortly before you take off, you don't know what other assets are going to be out there, if it's from another service, if it's other assets in the Air Force. When you take that amount of dynamism and uncertainty, how does that change training, and how does that change mission planning, and what can we do about that?
Well, let's start with mission planning. When Captain Holmes was an air-to-air mission commander, I would get an ATO that said, you have these 12 F-15s, you'll have a dedicated AWACS controller, you might have a compass call to do some jamming, and you'll talk on this frequency. Go, build us a mission, to get that done. And that evolved a little bit to, here's your Link 16 network, here's your crypto that you're going to use. Several things were added. And there was some ability to negotiate that with the AOC, with liaisons that you had there. Every unit had a liaison, but you pretty much took what they gave you and you built the best mission plan you could as you went forward. I think what we're looking at is being able to sit down in another kind of analogy of DevSecOps with the allocators and say, okay, they tell me, okay, you got these many platforms, you have these sensors, and you have access to this cyber and EMS tool. I think you have this data that'll be available to you. You don't care what sensor, but this database is going to be pushed forward to you as you need it, and a waveform. And then we'll work on tactics to put that together. So platform, sensors, data, non-kinetic tools, and a waveform. And then how are we going to do it? And what operators have kind of evolved to now, and the complicated scenarios they face, is they use contracts. So if you go to a red flag brief now, you'll hear lots of contracts briefed that are basically if-then steps. My job is to do this, and if I haven't done it by such and such a time, I have to tell everybody else that they can't rely on what I accomplished. So I think we'll lay out some steps there, and I think it'll be more of an iterative process with more negotiating. And then the final step will be to say, okay, now what do we take to configure this system to go accomplish this mission? And we'll push that out in a message format, kind of like the upgrade to your Tesla, that will set up the waveforms, that will set up the data links, that will decide the hierarchy, and will assign priorities. And then that can change as the mission goes, like Tim said. We may decide, the AOC may decide to push another upgrade, which gives somebody else charge of it. There's a higher priority, steal some assets to go do something else. And frankly, I think it may get down to stealing a waveform from your radar without you even knowing it to go take a look at a target of interest for tomorrow along the way with somebody working through the software to do all that. But it'll still take an operator's input, as we started with, a tactician, a mission commander, to try to make sure that what we're going to do has a chance to accomplish the mission.
So, Mike, so we're talking about in terms of developing tactics. Maybe are you talking about maybe relying on software to a greater degree to help formulate those plans or those courses of action? Used to be, or at least when I was in the service too, we kind of make these plans up more or less on our own based on our memory or experience or doctrine. But given the kind of the wide range of possibilities, if you've got a system of systems like NGAD, you're going to want to take advantage of some kind of mission planning tools in situ to help you kind of look at that whole decision space.
Yeah, and I think it'll likely start with AI generated electronic warfare techniques. A new waveform is seen or a new threat is seen. An AI engine quickly generates a response to that. It goes through an automated testing process and it gets pushed out to all the airplanes. This gets back to the other half of Dan's question now, which is training. So how do you prepare for this environment? And you have to prepare crew members and decision makers, but you're also going to be preparing these AI tools that are going to help you along the way. So you have to have realistic threat environment to train in, whether that's real or whether it's a virtual environment, but it has to be realistic, really down to the physics level, so you can have confidence that these things work. And then you want to be bringing all your tools together, including those algorithms, to be able to say, here's a suggested tactic based on what we've seen to the mission commander. We ran it through this wargaming engine and we say we got this results. And then somebody may say, okay, that's pretty good, but how about if we did this too? And then you run it again. Maybe you do that 4 or 5 times until you say, we can't get it done with these assets. You're going to have to give us something else. Okay, now we can get it done. Now you push the configuration and out the door you go.
And if I can pile on that, it isn't even just training. It's probably even some new labor categories.
Right.
One of the things that we've looked at, and Dan has heard, and you've heard me talk about this in my former life, figuratively, the combat support geek squad.
Right.
So some kind of military operator who is, not writing code like a DevSecOps person, but is technical about digital things, is doing mission configuration support, and in that regard, sort of like a maintainer, but probably a little bit more technical than a maintainer, at least in the more technical in the digital realm, but also has a dose of operational mission planning, and sits right at the intersection of those 3 things. We have the closest thing to that today in things like software engineering groups or JICOs, but it's really a new specialty that we really need to start thinking about developing to support this kind of operation.
Yeah, and if I can jump in, there's a lot of questions that have to be answered about a companion combat aircraft, and how will you organize those squadrons, and how will you handle those authorities? So who gets to decide what Tim was talking about? Who gets to decide we're going to do this differently? Is it the equivalent of a JICO somewhere? Is it the squadron commander that has 24 CCAs and they lost some airplanes, the algorithm's learning, they want to update it and use a different version of the algorithm? That's why we have to practice, and it's probably a combination of training and experimentation that'll have to happen. But that's why, my desire would be to go ahead and get our hands on 24 or 48 nascent CCAs. They don't have to be perfect. They don't have to meet the final requirements, but let's get them and let operators start training with them. And then we'll figure out and we'll refine their requirements from there. And put them together in an organization with 12 or 24 where a squadron has to start learning how to operate with them.
Right. And essentially, they're going to have to act as kind of an arm of the acquisition process too, because you're going to need them to be directly feeding into, in this case, the NGAD, program office, the NGAD PEO, to help inform how they design, the software ecosystem in which all these systems reside, and then how the systems actually need to evolve in terms of their attributes. So it seemed like you got to just couple these things.
Yeah, and I think another
that
thing
was a
that
statement or a question, but definitely agree. And I think that there's a cycle where today we've got that operational experience that we use to feed the acquisition and the engineering, but then it hopefully it comes around full circle, where once we gain experience with doing that, it pushes closer and closer to operational mission planning kind of timelines like General Holmes is describing.
So, a consistent theme that's come up here is this interplay, right, between development and operations. And I want to point out, this has come up both in the historical examples of the Air Force success and the mandate for managing this complexity in the future. But, Tim, can you speak a little bit to that? Why is mixing development and operations so important, and why is it so hard?
So we've got let's start with why is it so hard? And a lot of it is cultural and policy driven. We have a very rigorous, I might argue over rigorous, I like to say it mistakes the statistics 101 fallacy of mistaking precision for accuracy. But we love to study things to make sure that, first of all, we know exactly what the right requirement is. And then in a very waterfall model, we pass that down to knowing exactly what system we want to design to satisfy that requirement. And then from there, flow down to everything from how are we going to build it, how are we going to test it, how are we going to use it. That's kind of our legacy model. And it's one that's been built up over decades. And I know Dan and Bryan, you've both done studies on this going back to the McNamara era. But it really is based upon trying to solve legitimate problems, whether it was people out in a sandbox, pursuing pet rocks that don't satisfy an operator need, and we want to keep them focused, or we're worried about fairness in contracting and industrial competition, or we're worried about hitting performance values and safety and mission criticality. All good things, but they become baked into this very linear waterfall process. And I come back to, it's mistaking precision for accuracy. Who can tell me precisely to 6 nines of precision exactly what the threat is going to be 30 years from now, and exactly what the opportunities are going to be from a mission capability and a technology 30 years from now? That's the problem with the legacy model, even though it was all well-intentioned. So by making things operationally focused, first of all, we can capture a lot of the nuance. And General Holmes alluded to this. In our classic requirements process, we miss a lot of the details. English is a very imprecise means of communication. And it's even more imprecise when you try to make it precise by throwing it into a 1,000-page requirements document. So instead, by being able to have human beings in real time, go back and forth on, this is what I really mean. Oh, now I understand what you're talking about. Oh, but I can't do that, but I could do this. Is that good enough? That interplay, real-time interplay or near real-time interplay between operators who understand the operational problem and capability developers who understand the state of what's possible, allow you to very quickly converge on more precisely, truly accurately defined to a particular need and problem. And then if we can do it faster, you can really beat down that accuracy part of the equation. I know if I can only project, a year into the future, or better yet, if I can project a month into the future, now I've got a really clear sight picture, and I can start tailoring a capability to that sight picture. So that's the cycle we want to work toward. I'm not suggesting that with NGAD we're going to be redesigning airplanes on month cycles, but by being able to bring the details and the intuition and the understanding of the operator iteratively into that design process, we converge much faster on what's really needed.
Right.
And there are
some. You might be able. Go ahead.
No, I'll just real quick. We know that our traditional waterfall approach takes too long, is unresponsive. You end up finally getting things to the testers, and they're testing it against a requirement that they don't believe in anymore. And their goal is to test against a requirement. I think there are opportunities to pull the stages together into that chaos Tim talked about. In the early days of our ABMS program, recognizing the fact that our old system didn't work, we kind of drew a wall and kept the testers out. We did demos, but we didn't bring in the experts in the 53rd Test Wing or in the 505th Command and Control Wings test group that have that exquisite real life experience and are experienced operators that could sit down and say, that doesn't work for what we need. And you got to change the testing goal from, does that meet the requirement we wrote 10 years ago or 5 years ago or even a month ago, to, is that better than what we have now? And if it is, then let's throw it out there and then let's work on what comes behind.
One of the things that I find particularly exciting about this is, it seems this conversation, this concept of NGAD, starts with the assumption of there will be surprise. There's going to be surprise that comes from adversaries somewhere sometime down the road, and there's going to be surprise that comes from technology and innovation on the U.S. side. And this, we're talking about an acquisition structure that encourages innovation down the road, right? It encourages this deferred innovation, if you will. It might be a tactical innovation with new operational concept. It might be a new mission system or new mission capability that you're able to slot it in open, and you're able to keep your system flexible enough that you don't freeze all of that up front in a requirement. There's pieces of this with F-35, for example, that we've tried before, right? Or MIDS, a radio system, or it's sort of modular. There's a card that you can replace, but you still had to define the interface of that card in detail up front. What you're talking about here is really, it's a much more flexible model of, you keep that fluid, you keep it in software to allow change down the road. And again, that seems really exciting and a real hallmark. If we can pull that off, right? That's it seems like a powerful capability.
Yeah. So the question to me, I love the goal and the idea of, maybe I'm pushing that interface out at the last minute, defining the interface even between cards in a system if there's a new capability, but certainly between the different platforms and sensors and how we're going to do it. But the question is, so what has to change in the way we conceive of and acquire the systems that we're talking about, if we're going to deliver continuous innovation and if we're going to do things faster? The idea that we'll keep doing things the way we've done it and just do it a little bit better, I don't think will work. So what is it that we're going to do differently that will allow us to produce a different result?
And if I can pile on that, there are two models for this that historically we pretty much know don't work. At one extreme, I'll call it the government as integrator model. But I would argue the challenge we've had with government as integrator gets a little bit to what you were just describing, Dan. If the government is primarily a buyer, not a builder, then if you want to buy a bunch of different things that are going to come together in a broader architecture, I have to have that common standard that everything is just going to arbitrarily plug into, and I can go buy the widget, so to speak, without having to think too much about those interfaces and about those APIs. The other extreme is the large system integrator that we've also seen, several pretty dramatic failures in past DoD acquisition of. We just try to define an entire system of systems as a monolithic thing and issue a contract to one large system integrator. And to what we were just talking about before, you can't predict to that level of precision that you need to define that system of systems. So somewhere in between are models that are maybe hybrids that get to this vision that we're talking about. At one level is the government as integrator, not just as a buyer, but also as a builder. So all the things we were just talking about with new kinds of training and new kinds of workforce and labor categories, go to a government force that can, both uniformed and civilian, that can do the integration, build a custom translator, do a custom API, actually define some of the modification, the tactics that might go into an AI algorithm or something of that nature. And then we need to look at new business models where we can go get industry thinking in this sort of dynamic system integrator model. I'll call it a light system integrator. It's not so much a requirement to go build me a specific system of systems architecture, but more almost a services kind of model, of be on call to do integration for me. I think converging those two business models is where we ultimately start seeing this kind of composability and federated approach that we haven't been able to achieve in the past.
Yeah, it's almost an ecosystem model where you're having, like iOS or Android, you give your suppliers or your potential participants, a development toolkit. And then when they build the system in such a way that it's able to interface or interact with the predominant systems in that ecosystem, as opposed to having just a set of interfaces, then standards that are defined in advance and that we all have to adhere to down the road. So building, different instantiations of that systems of systems like we do in commercial telecommunications, rather than operating off a set of fixed standards that are defined and then unchanging. So one last area that's really interesting about this is because these new approaches to acquisition you're describing, Tim, that implies for the industrial base different changes, right? Because right now you've got a very kind of platform-centric, hardware-centric industrial base for which software is a supporting element. And in this model, you're going to want to have some providers that are strictly software providers that are building out the ecosystem, and then others that are mission system providers that just provide mission systems that'll be brought in and integrated by somebody else. And then your traditional platform builders are going to recede potentially as an element of the NGAD ecosystem, because the NGAD manned aircraft will probably be more expensive, and we won't be able to buy as many, and then we'll have to buy many more of these mission systems and weapons and other payloads or other CCAs. So how's the industrial base going to respond to that, and how can the department manage this transition?
So I think there are two fundamental implications of what you're describing. I think you've hit the nail on the head of what's needed to be able to be successful in this kind of model. What it really boils down to, and this is probably the single biggest challenge in this family of systems model, is every time I do a new variation, and I'm thinking specifically a new variation of platform, but frankly, it could also be a new variation of mission systems. It gets even messier. But let's just talk platforms. Every time I do a new variation of a platform, new platform cannot equal new program. Because historically, we do programs and the platforms associated with them, as you used the term before, ecosystem. They're really vertically integrated ecosystems. I've got NRE, I've got contract initiation, I've got manufacturing, I've got spares, training, all of those things repeated for every platform. So therefore, if I have N platforms, it's going to be N times the cost, and we very quickly go bankrupt in this family of systems model. And that's even before we get to the adaptability and the interoperability things we're talking about. So instead, we need government and industry working together to say, how can we look at a program as a family of systems where we have latitude to do different variants, and maybe the variants are much quicker turn. Again, just thinking platforms, maybe I do multiple different platform variants, sometimes small deviations, sometimes vastly different models. I probably have fewer numbers of each of those variants. They're probably on much faster program centers. And there may be even a little bit of competition where it's moving back and forth between different vendors for each of these iterations. But every iteration cannot be its own standalone, vertically integrated program. I need to get that scaling of number of variations to more like a log n, where n is the number of platforms or variations, or even something that scales slower than that, to be able to get something that's affordable while achieving the agility that I need. So getting to that level of flexibility within a programmatic structure is one critical element. And then the other one we've hit on a little bit already, but it's the notion of the primacy of software. So I may have situations where I need to go have very software intensive developers. And that could be actually people writing code. More likely it's some of these more light system integrators, integration, but still digitally oriented kind of functions that in some cases may act almost more like a prime, where they could be out there contracted to define and compose one of these architectures that, oh, by the way, happens to include a platform. So I think those are the two big business models we need to be moving toward. One where we can do major hardware systems more as a dynamic family of systems within a contained program structure, and then another one that's almost more of a services-based mindset of how we do the integration itself and the digital piece.
And we know that a commission has been chartered to take a look at the way we budget across the Department of Defense, and I think that'll be required too. So you could imagine a world where the NGAD program office had a budget that they could spend across these categories, across the connectivity, across sensors and platforms. As their studies illuminated better options, they could change the ratio of what they were going to acquire, and you could work through it that way. To get that talent, as you said, Tim, all inside the government probably won't work. So you probably got to go bring in some talent, and you probably will need to bring in talent that don't have a vested interest in one of the solutions, right? And fighting over which, are we going to buy 10 of these or 50 of those? You want somebody that's focused on how do we make the whole thing work, that doesn't have to keep thinking, if I propose a way this works that buys 10 more of my widget or 10 less of my widget, we're all going to be out of a job. So there's some things to think through there on how you get the capability in there. And we're always going to need the people that can build those platforms and that have the detailed technical knowledge and the program management knowledge of how to do that. But I think we're also going to need a new kind of contractor that can link everything together.
Yeah, Mike, that's a great point. That essentially you're talking about, the company or the entity that's developing the software ecosystem or leads the development at, in a lot of ways will end up being, the integrator, and will need to run gauntlets to ensure that new elements are going to be able to contribute and participate in the way that the program needs them to, which is where you get the DevOps approach with your operators. So they're very different business models for the DoD's industrial base to deal with.
On that line, Bryan, if I can just jump on that really quickly, I've got actually a couple of asks that I've been sending out to industry that really springboard off of what General Holmes just described. So first of all is I'm going and asking industry, what do we need to do on the government side to be better buyers of this kind of model? What are the considerations, whether it's anything from how we do contracting, how we do cost models? Are there other authorities that are needed? I'm actually very interested in industry's insights into that. How can we make sure that they can stay viable and make a profit, and at the same time satisfy the needs we have here? The other big thing we need is really good, solid operations analysis. Because while on the one hand, I'm very happy that General Holmes brought up the notion about the budgeting side of this, and we need to get to the point where we can create wedges that give us this agility within the wedges. At the same time, we need the tools to come up with quantitative analysis and justification of what are the boundary conditions. So it's, in some ways, it gets back to where I started with precision over accuracy. I want to get to a lot of accuracy on those boundary conditions, but then I want to live in a very systematized chaos and low precision in the middle, where I can constantly doing that maneuver and flexing and configuration. But we need new tools to be able to help define boundary conditions and create the feedback metrics that allow us to both justify what we need as well as maintain, sort of accountability against what we need.
Yeah, absolutely. That's the cycle you need for that deferred innovation, that Dan talked about, and to really explore that whole decision space that NGAD might be able to use. Well, thank you very much, Dr. Tim Grayson, General Mike Holmes, Dr. Dan Patt. Appreciate this fantastic discussion today about kind of the future for NGAD and NGAD's acquisition and new approaches to acquisition and R&D. Just a reminder that we are going to have a report coming out shortly from the Hudson Institute looking at new approaches to NGAD acquisition. We'll explore some of these ideas. We're hoping that you take a look at it. But for now, thank you very much for being here. And thank you to Kirsten Moeller for putting this together and making us all look smart at the end of it. Until next time, have a great day.
Thank you very much for the opportunity.